Hello, my name is Dan Kozin, Product Manager for Machine Learning Software and Developer Experience. I've been a product manager at Silicon Labs for the last 5 years, managing our embedded software platform. For the last almost 2 years, I've been focusing on our machine learning offering. Silicon Labs has a strategic intention of being in machine learning, and I am excited to be part of Edge Impulse's flagship event, Imagine. Today's talk is on bringing intelligence to the edge on the MG24. The MG24 is our recently announced chip. Silicon Labs is a market leader in low-power wireless microcontrollers, and the MG24 is one of our highest performance chips to date. In this presentation, I'd like to introduce our company for those unfamiliar with us, let you know where we fit in that large spectrum of machine learning solutions, introduce how we make machine learning accessible to our developers, and finish up with example demos of some relevant use cases that are running on our chips. Silicon Labs is a billion-dollar, pure-play, IoT fabless semiconductor company focused on wireless microcontrollers. We serve the smart home, smart industrial, and smart city markets with worldwide presence in Asia, Europe, and the Americas. We have the largest set of wireless protocols available in the market with Bluetooth, Wi-Fi, Zigbee, Z-Wave, Thread, and more. And these are all in production and powering over 1 billion devices around the world. We are in all the major ecosystems that are driving end user adoption, and we continue to innovate by supporting and driving new protocols like Matter. Customers buy us for 3 reasons. Low power. We are the low-power wireless microcontroller of choice. We optimize for long-life battery-powered devices. Multi-protocol. We simplify the ability to develop devices that support any combination of the wireless stacks we deliver. And security. We are the first in our space to obtain PSA 3 certification. And there will be a 4th reason. Machine learning. We want to make machine learning easy for developers to add it as a value-added differentiator to their IoT products. We want to unlock the potential of machine learning being developed and deployed at the tiny edge. And that's why we team with partners like Edge Impulse, who's bringing machine learning to the masses with their innovative and easy-to-use machine learning development platform. I'd like to expand on the term tiny edge further and level set for everyone. Even though it should be nothing new for most of this audience, I'd like to make sure it's clear where Silicon Labs plays. The edge is a very widely used term in our industry and has encompassed anything from enterprise edge to the network edge to border routers and even large data centers. Anything that's not cloud computing is talked about as the edge. We are distinguishing the part of the edge that is the very end of this digital chain. This tiny edge is the last leaf device that is typically wireless, resource and power constrained, cost sensitive, and becoming ubiquitous. It's driving the volumes that are now being talked about in the trillions. We call this the tiny edge, and the Silicon Labs family of products live in this space. The TinyML migration is the migration of AI ML from the cloud all the way down to that power and resource constrained edge. The advantages are clear: reduced bandwidth, no latency, increased security, cost reduction. But the challenge is how to find the right split of responsibility of the AI and machine learning between the cloud and the tiny edge to achieve a system that solves real-world problems and produces a measurable ROI. Being adaptable and providing the right tools to prototype, iterate, and validate your creative solutions is how we intend to help bring machine learning to the tiny edge. So what does Silicon Labs bring to the table? We are a pure play company in the IoT that's been developing our platform for over 15 years. We cover the widest range of wireless protocols in the industry that's running on over 1 billion devices and thousands of products. We deliver a market-hardened radio combined with an MCU and the industry's most capable secure element. With the introduction of our latest XG24, we're going full on in the machine learning market by including an integrated ML accelerator paired with our CortexM33 based SoC. Compared to a straight Cortex, the ML accelerator can provide up to 8 times faster inferencing and require as little as a sixth of the energy. Silicon Labs is known for its low-power wireless microcontrollers, and we are continuing to bring that value to the market with our integrated accelerator. We have also approached this knowing that machine learning developers are not created equally, and that these developers should be able to pick the right tool for their needs. Developer experience is strategically important for us, and we make sure our developers have the easiest time to create applications they want to bring to market. Machine learning is a horizontal technology that has an enormous range of possibilities to add value at the tiny edge. The key is finding the right balance of accuracy and fit. What are some viable applications at the tiny edge? Machine learning is a horizontal technology applicable across a wide variety of applications and market segments. It's helpful to describe these applications in the order of increasing chip resource requirements. When looking at an application, the amount of chip resources will increase, primarily driven by the data throughput and the complexity of the analysis. On the leftmost column here are applications based on the simplest type of sensors like accelerometers, temperature or pressure sensors. The applications can be ones like preventative maintenance, health analysis through wearables, or even fall detection. Next are applications using a mic for non-voice audio pattern matching. Applications can be glass rate detection, shot detection, machine malfunction, or even breath monitoring. Then the complexity increases when you detect voice or spoken words. Applications here can be voice command smart home devices or wake words for voice assistants like Alexa or Siri. And finally, video input is at the higher end, both in data rate and complexity. As the camera resolution and frame rate increases, so does the processing requirements. Within our portfolio today, we can cover low-resolution vision applications such as object recognition, people counting, or even fingerprint matching. Edge Impulse's FOMO block, where FOMO stands for faster objects, more objects, that FOMO block even further optimizes object detection by up to 30 times less processing time required. We have a demo later that shows people counting using Edge Impulse's FOMO block and the XG24 dev kit and an off-the-shelf RGCam from SparkFun. We tend to segment applications into these 4 segments: sensors, audio, voice, and low-resolution vision. What you can see is that the applications are vast and numerous, and really just limited by one's imagination and the resources available with the embedded processor. Let's look a little deeper into what are some of the use cases we may see and how they can benefit from machine learning. A very well-documented use case is preventative maintenance. This replaces the current sensor deployments that are sending all the raw data to the cloud to be analyzed for anomalies looking for an early indication of product failure. Machine learning can do the anomaly detection at the sensor without sending the data to the cloud, therefore eliminating the bandwidth congestion and simplifying cloud processing, essentially reducing the cost of deployment. In this case, the application may benefit from supervised learning trained with classified patterns, or unsupervised learning that learns the patterns in the field without needing to acquire a data set for training. There are many ways to accomplish this, and the customer will ultimately determine which fits best for their application. Wearables for health or even elderly care is another great use case to talk about. I'm not talking about the standard watch type devices. The market is flooded with these, but more of the wearables that are small coin sized and can be attached to the skin, like blood glucose monitors, or coin sized devices that can be attached to clothing. Simple IMUs that monitor movement or PPGs that can monitor heartbeats can be used to identify normal activity and abnormal activity. For the elderly that may not be comfortable with these highly versatile watch-type flexible smart devices, they will probably respond better with fixed function parts. And caretakers that may not be present all the time can have better insights into the health and well-being of their loved ones. Voice is a big area for us. In the smart home market, voice control is becoming more accepted and widely deployed in the household. Alexa, Google, and Siri are being deployed to control all the functions in the house, and all kinds of devices and skills are being developed to control them all through voice. With the smart devices at the home already, like switches, appliances, and lights, the idea of eliminating that extra puck and enabling these devices to recognize the wake word and stream your commands to the cloud becomes attractive and saves money. The switches you're already planning to replace can be an extension of Alexa with machine learning at the tiny edge, recognizing your wake words and voice commands. Security is another area. This is where a combination of audio signature detection, voice detection, or even object detection can be deployed. For instance, using machine learning for glass break can significantly reduce the false positives that current products on the market suffer from. Or think of smoke alarms that are on the ceiling and too hard to reach. How would you like to be able to just say, "Be quiet," to turn off that alarm? Or think of video doorbells that use power-hungry processors for face recognition, but need a front end to detect the difference between a face or a bug before firing up the high-powered processor. Our low-powered devices with low-resolution capability can be a video wake-up to help save battery life. There are so many use cases that are possible, and they are all very cool. But the key to being successful is whether it provides value and even an ROI for the customer. With Edge Impulse, we hope to tap into this ecosystem of creative developers and deliver products that bring real value to those end users. So let me take a few minutes to introduce the BG24 and MG24 devices that are part of our Series 2 platform. Across our whole portfolio, we have sub-gigahertz radios for longer range proprietary protocols and 2.4 gigahertz radios for Bluetooth, Wi-Fi, and 15.4 mesh protocols. The XG24 devices are our highest performing chips with a 2.4 gigahertz radio and optimized for battery-powered IoT devices. One of our main strengths is our radio, and these new devices are class-leading SoCs with superior performance. We support up to 19.5 dBm with sensitivity greater than minus 104 dBm for both 15.4 and BLE long range, which translates to a robust length providing more range and reliability. The devices also have very simplified RF match, which doesn't need a typical front end and translates into a lower cost solution, especially when higher transmit power is needed. Like all our other Series 2 devices, these are based on the CortexM33 running at 78 megahertz. They also have 2 additional cores, one dedicated to the radio and one for secure vault functions. The flash is up to 1.5 megabytes and has up to 256 kilobytes of RAM, making this a target device to run Matter or to run quite sizable models when combining machine learning with BLE or our lower footprint mesh protocols. While this is a high-performance SoC for edge devices, we have managed to keep active and sleep current consumption very low, almost half the consumption of our previous products. For instance, 0 dBm TX power, transmit power is at 5.1 milliamps, while we are down to 4.4 milliamps receive on BLE for both the radio and MCU, and 5.1 milliamps for 15.4. What's really exciting about this chip is the sleep current. We're at 1.3 microamps in sleep mode. When combined with our low active currents, we really extend the battery life when compared to our previous generation products. We have great low power peripheral support through our UART and SPI interfaces that allows peripherals to run while the MCU is in sleep mode. There's also an integrated 20-bit ADC that allows for ultra-high precision measurements, plus support for other standard peripherals using the I2C bus. That's just the standard microcontroller features. What's really exciting is the introduction of our own proprietary hardware accelerator focused on machine learning. This accelerator is a matrix vector coprocessor that is very well suited to offload many of the TensorFlow Lite for Micro kernel operations like Conv2D and others. When running common models, we have shown up to 8 times faster inferencing and up to 6 times lower power consumption when compared to the same models running on a standard Cortex. We support TensorFlow Lite for Micro natively, and this coprocessor offloads some of the most compute-intensive TensorFlow Lite operators so the Cortex can manage the rest of the application. We are really excited that Edge Impulse supports these chips and fully leverages the accelerator. So any projects built on the Edge Impulse platform will be able to be leveraged to leverage all the advantage and power of these chips. Just to show you some details about the accelerator, here are some measurements comparing the hardware accelerator versus the Cortex MCU running some standard models. The left graph shows inferencing time comparisons, the amount of time it takes to run an inference cycle. The right graph shows power consumption comparisons, the power consumed when running that inference cycle. Each graph shows 4 standard TinyML benchmark models, ResNet, MobileNet V1, and 2 keyword spotting models. So the advantage of the accelerator is quite noticeable when looking at overall system power consumption. Basically, the inference runs faster, which allows the CPU to get to sleep faster. Plus, the execution of the inference in the accelerator runs at a lower power than it would if it was running in the CPU. So overall, the power reduction is reduced on 2 dimensions. It runs faster and at lower power. You can see that different models will vary with how much power is saved based on the model architecture, but this shows how we focus on performance and low power as some of our key value propositions. ML Commons is an industry consortium with 39 founding members, such as ARM, Google, Intel, Qualcomm, NVIDIA, Facebook, Microsoft, and other big players focused on promoting machine learning best practices across the industry. One of the main focuses of this group is benchmarking, and they have TinyML benchmarks for different vendor chips. We participated in ML Perf Tiny 0.7, which was over a year ago, and this shows our inferencing comparison with other vendors in the market with Cortex class processors. The graph shows energy consumption per inference in microjoules. It's just the inference portion of the execution, not the whole application. But the point here is our low energy usage, shown in the red bars, compared to other vendors of similar class products. The main message is that we are all about low power wireless microcontrollers, now running whatever machine learning applications you can develop to fit on the chip. Here I'd like to mention our complete line of chips and say that machine learning is not limited to just the recently introduced XG24 products, but it runs on all of our available chips. We have Series 1 SoCs based on a CortexM4 with both sub-gigahertz and 2.4 gigahertz radios. And we have our Series 2 SoCs that we were just talking about based on the CortexM33 with the same radios plus advanced security. All of these chips support machine learning. So everything I talk about in this presentation having to do with building machine learning applications apply to all of our chips. You only need to develop one application and it will be able to run on any configuration we sell, with or without the machine learning accelerator. The only key aspect about this flexibility is for you, the developer, to find the right balance between the machine learning functionality or breadth and accuracy and the resources of your chosen chip. There are 2 chips called out here, one for the Series 1 family of chips and one for the Series 2 family of chips. The Series 2 we've been talking about is the XG24 with the hardware accelerator, and we have a developer's kit called the XG24 Dev Kit. That's what you would use with the Edge Impulse Studio for an out-of-box experience to prototype and test your application. The other one called out shows another dev kit that you can use with the Edge Impulse Studio. We call this the Thunderboard Sense 2, and it has an MG12 Series 1 product based on the CortexM4 running at 38 megahertz without an accelerator. If you happen to have one laying around, you could use that with Edge Impulse too. The key takeaway is that we support machine learning across our whole portfolio with the same developer experience so you can find the part that meets your needs. I'd like to touch on how we've implemented machine learning on our embedded processors to explain how we can support machine learning across the whole product line. First, we support TensorFlow Lite for Micro natively. That means in our standard embedded software, we have the TensorFlow Lite for Micro inference engine integrated as a standard component in our SDK. With a Cortex MCU, our software supports TF Lite kernels and some software optimized TF Lite kernels. When the hardware accelerator is involved, shown as the MVP on the bottom right diagram, we have implemented accelerated kernels where appropriate. So our software will automatically choose the hardware accelerated kernel if present first. If not, then the software optimized kernel will be chosen. And if not that, then the standard kernel. In all cases, the same TF Lite model is used without needing to make any changes. Okay, let's get into how we look at creating machine learning applications for our parts. For our devices, there are two separate workflows. One is the traditional workflow used to create a standard wireless application. There's the tool chain based on the developer's favorite IDE, which could be Silicon Labs Simplicity Studio, and the output is the hex file that is loaded onto the embedded device that runs in the field, as the diagram shows. But as you know, machine learning has a completely separate workflow of its own. And what you want is to add machine learning as a value-added feature to an existing wireless application. We call this machine learning as a feature. In the world of connected embedded devices, people are looking to enhance their offering by adding machine learning technology to their existing products. And this is how we do that. In this case, Edge Impulse is the model building workflow that produces a library, or we call a component, and that component is integrated into your wireless application. And what you do as a developer is to find the right balance of model accuracy and model size that will fit in the available RAM and flash of your target part. Just to level set, let's expand the machine learning workflow into its main steps. There's the data set creation, and Edge Impulse has a nice interface to manage this data. There's training the model, and Edge Impulse's use of AutoML really makes this easy to find the best model that fits in the available space. There's testing, and finally, converting into an optimized format for the embedded device. Edge Impulse has a great tool for embedded developers, but we recognize that not all developers have the same needs. What we find is that developers have a wide range of skills, and we want to make sure that our developers are able to pick the best tool for their application and their skill set. So we segmented developer skills into three broad categories: expert, explorer, and solutions. For Silicon Labs products, we define a machine learning expert as a developer that is very experienced with TensorFlow and Python. The expert tools require that the developer have these skills or is at least willing to learn. On the other side of the spectrum, we call it the machine learning solutions. This category assumes machine learning technology is used to add value to the product, but does not require any knowledge about machine learning, nor the need to learn it. Instead, these are black box solutions that can be used as value-added feature to a product. They tend to be very tied to specific use cases. And in the middle, we call it the machine learning explorer. The skills expected here are to know the basic machine learning concepts and workflow, like we showed in the previous slide, but to have an easy-to-use interface that curates the developer through the end-to-end workflow needed to implement machine learning as a value-added feature in their wireless product. We classify Edge Impulse as an explorer tool. The developer doesn't need to know all the details of programming TensorFlow to create a production-worthy model. But the developer should know the basics, like creating a data set, training a model, testing it, and optimizing it for embedded developer. And Edge Impulse does a great job curating that whole end-to-end process of creating a model. So by segmenting tools into these simple categories, this allows a developer to understand what skills are expected of them in order to use the tool effectively. You can still have someone who qualifies as an expert use a solutions tool. This categorization just helps the developer understand what skills they need to engage with that tool. And here's a current view of tools and partners that are available to develop machine learning on our chips. For the expert, you can use TensorFlow directly. The ML expert can also use our machine learning toolkit, which we call the MLTK, which is an open source, self-serve, community-supported Python package that wraps around TensorFlow. For the explorer, you have Edge Impulse, and there are also solution tools for embedded developers that don't know machine learning or even want to learn, but understand these solutions are targeted for very specific use cases. This slide shows the tools from a different perspective and looks from a workflow perspective and how the different types of tools cover the workflow. One main takeaway is the line showing ML solutions tools bypass the whole machine learning workflow. ML solution tools just need the application-specific input, like typing in the keywords or using unsupervised learning to detect anomalies in the field. With a solutions tool, you get a pre-trained and configured machine learning library that's ready for integration into your wireless application. No machine learning expertise nor understanding of this workflow is required. On the other hand, the Explorer tools like Edge Impulse cover the complete end-to-end workflow from creating the data set to generating a library to integrate into your wireless application. There are two types of expert tool workflows. One is called Bring Your Own Data and works with the Silicon Labs MLTK. If you use the MLTK, it covers the training, testing, and conversion, but you are expected to provide the complete data set for model training and testing. The other is called Bring Your Own Model, which assumes you're using TensorFlow directly and will use the MLTK profiler to display the characteristics of your trained model, such as RAM usage, flash size, and CPU utilization. In this case, you're doing everything needed to create your production quality model and only using the MLTK to confirm this model fits. Ultimately, what you get is a range of options with a range of flexibility. But increased flexibility requires an increase in machine learning experience. And finally, I'd like to introduce the developer kits that we suggest to use with Edge Impulse. The one on the right is the XG24 kit, which includes our recently introduced MG24. The chip includes the AI ML hardware accelerator and the largest flash and RAM configuration at 256 kilobytes of RAM and 1.5 megabytes of flash. It runs at 78 megahertz and includes several useful peripherals, such as 2 digital mics, a 6-axis inertial sensor, pressure and humidity and temperature sensors, plus a UV and ambient light sensor as well as a Hall effect sensor. This also has a quick connector and a 20-pin breakout that can be used to connect external peripherals like the RGCam low-resolution camera for image input. This is a small size board that can be powered with a coin cell battery and remotely connected through Bluetooth for cable-free operation. The left shows our Series 1 dev kit called the Thunderboard Sense 2. If you have one, all the software will run on that as well. However, we recommend any new development occur on the XG24 dev kit. I've told you a lot about our company and our products and how we look at machine learning. Let's take a look at some examples we have that illustrate the power of machine learning on our chips combined with Edge Impulse. These examples are in the higher end of the spectrum of processing requirements, those vision use cases like image classification and object recognition. The first demonstration was created in-house using our own MLTK, that open source, self-serve, community-supported Python package for the ML expert. The second demonstration shows an example of using a 24 by 32 low-resolution IR camera in a people counting application. The third demonstration we created with Edge Impulse using their FOMO block to run optimized object detection with a higher resolution camera for people counting. We are super excited about Edge Impulse's ability to squeeze out the most power from our chip with their innovative video capability. The first demonstration uses a higher res RGCam connected to the XG24 dev kit. It's an example of image recognition and shows the inference recognizing 3 different hand patterns from the familiar rock, scissors, paper game. This model takes about 80K of flash and 137K of RAM. For those inclined, you can see how this demo was created in the MLTK tutorials section under image classification. This shows a live demonstration where the recognition is being printed in the console window on the right side. You can see the recognition printed by the label each time the hand is being presented. In this case, scissors, rock, paper, paper, scissor, and rock. The second demonstration uses a 24x32 low-resolution IR camera. These two images show the kind of resolution captured by this camera. On the left is a hand with thumbs up, pretty recognizable. On the right is what I'll be demonstrating next. It's a picture from the ceiling in the kitchen area at our office, and the white images are the top view of people we are looking down on. The setup uses an IR camera available through SparkFun, connected to an XG24 dev kit. The Raspberry Pi is just being used to capture the camera output for displaying on the PC in this demo, as well as being a terminal to display the serial output. It's definitely not needed in a real deployment. What you see on the right side is the image from the ceiling into that kitchen area, and it starts off empty. On the left is the terminal showing the number of people detected. You saw one person arriving from the bottom, and there's this bit of a shadow effect. The images are coming in at about 2 frames a second, but the system is properly recognizing there's only one person present. And then another person arrives from the top of the frame with that same shadow effect. And the system is properly detecting there are 2 people in the kitchen. And then one person leaves, and the system shows one person detected. And then the last person leaves, and the kitchen is empty again. The third demo was a collaborative effort with Edge Impulse to show how we can push the boundary of processing using our accelerator. This is a people counting demo that uses a webcam pointed to an open live market in Japan. The video you're about to see is one of my colleague, Isaac Sanchez, on the show floor of Embedded World showing this demo in our booth. There's a lot going on, so I'd like to prepare you a bit. The core functionality to notice is our XG24 dev kit hooked up to the same RGCam camera we saw in the first demo and using a 64x64 RGB image. The application running on the MG24 also uses Bluetooth to send the people counting inference results to a smartphone for display. So this demonstration is running on a wireless SoC using Bluetooth to communicate the results out. What you will also see in the demo is a large flat screen showing internally how the object detection is actually operating. You'll see the actual image being processed with the red indicator showing that people are being detected. This is purely part of the demonstration to show you what's happening internally in real time. Let's enjoy the demonstration.
All right, so today we are highlighting our machine learning at the tiny edge, and it features our EFR32 MG24 dev kit. That's what's pictured here facing us. You can see the MG24 SoC. Connected to it is an ArduCam 2 megapixel camera, and it's facing a Raspberry Pi display, which is simulating basically a pathway filled with people. And what we're trying to do is detect objects and the probability that that is a person. So what we're outputting here is a very low res image, and if you're wondering why it's so blurry, that is intended. So with a constrained device that only has 256K of RAM, we have to have low resolution images, but it opens up to applications such as an occupancy sensor for things like a factory, or people wanting to track their workers in an emergency situation for fire escape. there's a very well need to know how many people are in the room, not just that there are people in the room. So Edge Impulse has helped us develop an end-to-end solution where customers can do their own training of data sets, as well as deployment to a CortexM 32 device. What you see on the screen is the object being detected as a person based off of only 100 samples, so that's 100 images used to train this device. That's why some of these blobs are missed, others are picked up, but you also see a probability that that object is a person. Over here is the actual CLI, or it's basically just a serial output of the inferences. And so because we are able to offshoot a lot of the ML computations to the AI accelerator, and enables the CPU to process quite a bit. So not only is it processing the model, it's also using that memory for our BLE application, the wireless connectivity stack. In this case, we're using Bluetooth, and we're also updating via BLE notifications, the same inference outputs. So basically, the sensor data then is basically going to be from the camera, and the inference is the output of our machine learning model. And so what we're highlighting here is you are doing the computation at the edge, disconnected from cloud computing. So this saves on basically the economics of transferring the data via wires. That's very much takes up a lot of energy, as well as clears up a lot of issues with network trafficking, and saves on costs on managing that data, especially when you're talking about a lot of like a fleet of devices all doing similar things. And that is really machine learning at the edge in general, is disconnecting from the cloud, saving on those economics of the data transfer.
Thank you, Isaac. It's time to summarize what I've talked about in this presentation. First, we support machine learning integrated with our proven set of wireless stacks, enabling single chip solutions for low power IoT devices that leverage machine learning as a value-added feature. We support TensorFlow Lite for micro natively, but also other classical machine learning methods depending on the software partner. We enable customers to choose what's best for them regarding tools. And we have dev kits available with easy out-of-the-box experience to enable quick proof of concepts. We cover a wide range of use cases that's limited only by your imagination. And we've announced our hardware accelerator to enable a wider set of use cases while still maintaining our low power value proposition. And I'd like to leave you with the only resource you need from us, scilabs.com/AI-ML. It's our machine learning landing page from which you should be able to find all the different applications and examples and descriptions you need to learn more about Silicon Labs and machine learning. Thank you very much, and I look forward to answer any questions you may have.